In this video, we're going to look at an example of the domain of a composition of two functions. So we have f of x is equal to the square root of x minus 9, and g of x is equal to x squared. This one asks us to find f composed with g of x and g composed with f of x, and then asks us to find the domain of each. F composed with g of x is f of g of x. So g of x is the same thing as x squared. So if we put x squared into the function of f of x, we get square root of x squared minus 9. For g composed with f of x, that's g of f of x. F of x is the square root of x minus 9. Plug that into g, we get the square root of x minus 9, the whole thing squared. When we simplify this, the square and the square root cancel each other, provided that the x minus 9 is greater than or equal to 0, and that's important for the domain piece. You might be tempted to ignore this condition here and just write x minus 9, and we'll come back to that here in a second. All right, for the first one, we need to make sure what's under the square root is non-negative. So we need x squared minus 9 is greater than or equal to 0, or if we factor it, we get x plus 3 times x minus 3 is greater than or equal to 0. That expression actually equals 0 when we get x is equal to plus or minus 3. That means we need to consider three different intervals here. Something less than negative 3, between negative 3 and 3, and greater than 3. If you're less than negative 3, say you plug in negative 4, then this would be this factor would be negative and this factor would be negative. So the product of those two factors would be positive. If we plug in something in between negative 3 and 3, say 0, then this factor is positive and this factor is negative, so the product is negative. If we plug in something bigger than 3, say 4, both factors are positive, so the product is positive. We're looking for the positives, so the domain will be negative infinity to negative 3, union 3 to infinity, and we include both 3 and negative 3 because it's okay if it equals 0. We just can't be negative. I mentioned this above. For the g composed with f of x, we're worried about the domain. We have to be careful. This g composed with f of x simplifies to that x minus 9 without a doubt. However, that's only true if what's under the radical is positive. The x minus 9 is positive. So in order to be able to go into f of x, my x has to be 9 or bigger, right? This x minus 9 has to be greater than or equal to 0. So the domain of the composition is 9 to infinity, and include the 9, even though it looks like it should be all real numbers because of the way it simplifies. But again, remember, for a composition, it has to be able to go into the inside function, which is why for looking at domains of compositions, it's better to look at this step for the domain than it is to look at this step.